This is an overview study of the Freescale LIN system, MC33911. Welcome to the training module on the MC33911. Here we study the basic interface of LIN and its applications. The LIN protocol is mainly intended to support the control of mechatronic elements found in distributed systems for motor vehicle applications, but of course it can be applied in many other fields. The LIN protocol concept is a multiplex communication system whose level and associated performance are clearly positioned below what we can expect from a CAN controller area network. It is very different from and much simpler than CAN. It is even simpler than the I2C bus, being based on the concept of a subnetwork containing only one master with a finite set of slave nodes. The LIN standard encompasses the specifications of the transmission protocol, the transmission medium, the interface between development tools, and the interfaces for software programming. LIN guarantees the interoperability of network nodes from the viewpoint of hardware and software and a predictable EMC behavior. The protocol specification describes the data link layer of LIN. The transport layer specification describes how to transport data that can be up to 4,095 bytes. The physical layer specification describes the physical layer, including bitrate tolerances, etc. The application program interface specification describes the interface between the network and the application program. This page gives you a brief introduction of a LIN application. In a motor vehicle, there are numerous network nodes / participants that operate satisfactorily at this performance level, such as a sunroof, open, close, inclination, etc., rain detector, automatic headlight switch on, seats, all seat adjustments and functions, top of the steering column, column mounted controls, etc., doors, window winders, etc., wing mirrors, de-icing, windscreen wiper control, interior light control, etc. The 33911 is a Serial Peripheral Interface (SPI) Controlled System Basis Chip (SBC), combining many frequently used functions in an MCU-based system, plus a local interconnect network LIN transceiver. The 33911 has a 5-volt 50 milliamp low dropout regulator with full protection and reporting features. The device provides full SPI readable diagnostics and a selectable timing watchdog for detecting errant operation. The LIN protocol specification 2.0 and 2.1 compliant LIN transceiver has wave shaping circuitry that can be disabled for higher data rates. Here we show a functional block diagram of the MC33911. It has 4 major blocks. The first block being a power supply which has an integrated inbuilt voltage regulator. The second is the analog circuitry block which has a watchdog window, a wake-up function, digital and analog input, and temperature sense. The third block consists of an MCU interface, an output control with internal SPI interface, reset and IRQ logic, a LIN interface control, and pulse width modulation control. The fourth block consists of a high side driver, low side driver, and a LIN physical interface layer. The 33911 offers 3 main operating modes: a normal run mode, stop mode, and sleep low power mode. In normal mode, the device is active and is operating under normal application conditions. The stop and sleep modes are low power modes with wake-up capabilities. In stop mode, the voltage regulator still supplies the MCU with VDD, limited current capability. While in sleep mode, the voltage regulator is turned off. Wake up from stop mode is initiated by a wake-up interrupt. Wake up from sleep mode is done by a reset and the voltage regulator is turned back on. The selection of the different modes is controlled by the mod 1 and 2 bits in the control mode register. The output is a high-side driver intended to drive small resistive loads. The high-side switch is controlled by the HS1 bit and the high-side control register, HSCR. The high-side driver offers additional direct control via the pulse width modulation input pin, via the SPI control. If the HS1 bit and the pulse width modulation HS1 are set in the high-side control register HSCR, then the HS1 driver is turned on if the pulse width modulation pin is high and turned off if the pulse width modulation pin is low. This page gives you information about the low-side switch present in the MC33911 device. Each low-side driver offers additional direction control via the pulse width modulation input pin. If both the bits LS1 and pulse width modulation LS1 are set in the low-side control register LSCR, then the LS1 driver is turned on if the pulse width modulation input pin is high and turned off if the pulse width modulation input pin is low. Each low-side driver signals an open load condition if the current through the low side is below the open load current threshold. Each low-side driver has a current limitation. The LIN bus pin provides a physical layer for single-wire communication in automotive applications. The LIN physical layer is designed to meet the LIN physical layer specification. The LIN driver is a low-side MOSFET with thermal shutdown. An internal pull-up resistor and a serial diode structure is integrated, so no external pull-up components are required for the application in a slave node. The fall time from dominant to recessive and the rise time from recessive to dominant is controlled. The symmetry between both slopes is guaranteed. This page shows an application diagram of the system acting in the slave node. Here the slave unit is capable of controlling a mirror unit according to the master commands and reporting its current status back to the master. The 3399 is designed to support the LIN protocol specification 1.3 and the 33661 is designed to support revision 2.0. This page shows the mirror system concept. The LIN master unit controls both the left and right slave units via the LIN bus according to the commands on the superior bus, example the CAN bus, or to the signals from the keyboard. Each slave unit controls a dedicated mirror unit and reports back in its state to the master unit via the LIN bus. The slave unit is capable of controlling a mirror unit according to the master commands and reporting its current status back to the master. This page gives you an application diagram of a DC motor pre-driver, which is used for a motor-actuated application in the vehicle, like a power window. Here the setup is controlled by the main MCU, which controls the communication between the slaves through the SPI communication and UART communication buses.